This is lesson 29 for 8th grade, and today we're talking about ratio. And today will be kind of a quick introduction to it, but we're definitely going to spend a lot of time on ratios this year because it's a very important part of math, especially for the future in algebra. Ratio is what eventually we're going to relate to graphing and being able to find the slope of a line, which is a very big part of algebra. So this is a very big lesson, and though today's introduction won't be that long, I assure you that we're going to hit it pretty hard the next few days and throughout the year, and do a lot of examples involving ratio. So today, since we're just starting with it, even though we may have seen it before, we want to learn what a ratio is by definition. We want to know how to write a ratio. We want to know how to set up a ratio, and that's a lot of times the biggest part of all of this, is being able to set that ratio up. And once it's set up, how to solve for a ratio problem. So I would say this step is the hardest one. Once you get it all set up, it seems to be fairly simple to solve for a ratio, and we'll have a few different ways to do that. Alright, so if we look at this slide here, a ratio is a comparison of two numbers by division. So here's our definition. We're basically comparing two numbers by division. For example, if there are 12 girls and 16 boys in a class, then we can express the ratio of girls to boys as a reduced fraction. So girls to boys, that would be our ratio. And remember that this division bar means to divide. So we have 12 girls to 16 boys, which reduces to 3 over 4. So we read this ratio as 3 to 4. And our next objective here shows us 4 different ways to write this ratio. We could use it with the word 2, 3 to 4. You'll hear me say that quite a bit. You can write it as a fraction, 3/4, or 3 to 4, if you think about it this way. Write it as a decimal, turning 3/4 into 0.75, or with a colon, which is seen often as well, 3 to 4. Okay, basically saying for every 3 girls there are 4 boys in the class. So those are different ways we can write it, and this is what a ratio is. Now, can we identify that in a problem? Let's take a look at that. There are 9 girls and 15 boys in a class. What is the ratio of boys to girls in the class? Okay, well, they want boys to girls, so we're going to write boys to girls. For me, I like to do things with the fraction bar. That's going to help us relate to algebra later, because that's how they do things in the algebraic world. So I like to use this method here, and then whenever you talk about it, I suppose I would use, well, I say it like this, but when I represent it on paper, I use this right here. So setting up a ratio here, boys to girls, we've got 15 boys and 9 girls. What is the ratio? Alright, so same thing down here, basically just different numbers. So 15 boys and 9 girls. Alright, now we can reduce that because I know that 3 goes into both of these numbers. So we can divide by 3 here. And we should get 5. 9 divided by 3 is 3. So our ratio of boys to girls is 5 to 3. And you could write that any way here that we wanted to. 5 to 3, 5 over 3. We could turn it into a decimal, or 5 colon 3. Turn it into a decimal, you actually have to divide. So if we did that, 3 goes into 5, or 5 divided by 3. 3 goes in here once. 2, never decimal. Drop that down. 3 goes into 20. 6 times. Subtract, we get a 2 again. And we're going to keep getting 20s. So 1.6 repeating would be the decimal for that. probably not the best way to do that one. To leave it as a decimal, but 5 to 3, that's basically what we're looking for there. You can leave it as a fraction if you want. That's the way I do it. Alright, let's take a look at this one. A 30-foot tall tree casts a shadow 18 feet long. What was the ratio of the height of the tree to the length of its shadow? So, it's 30 feet tall. This would be our height. And we're doing ratio of the height of the tree to the length. So that's how we're setting up our ratio here. Height of the tree to the length of its shadow. Length of the shadow, 18 feet long. So here's our length. Alright, so we've got 30 feet to 18 feet. And we can reduce that. Remember that units also cancel out when they're above each other in a fraction. So basically we have 30 to 18. We can divide by 6 would be a good one to use. 30 divided by 6 is 5. 18 divided by 6 is 3. So once again we get a ratio of 5 to 3 there when we look at the height compared to the length of the shadow. Just double checking there. Yes, we do get 5 to 3 again. Thought it was weird they gave 5 to 3 for 2 different answers, but that works out. Alright, so here we have, in some situations, we round numbers to express a ratio. For example, in a day of stock market trading, perhaps 789 stocks gained value, 597 lost value. So the ratio of advancers to decliners, or gains to losses, is estimated as 800 over 600, which reduces to 4 to 3. So basically they took their 789, rounded it up to 800, took their 597, rounded that up to 600, and approximately they estimated that it's about a 4 to 3 ratio. This happens a lot because a 4 to 3 ratio is much easier to deal with than trying to figure out what this kind of ratio would be. So we like to have things pretty simple for ratios if possible, unless they're looking for exact answers. And we will be doing that later when we're actually solving some different types of problems with ratios. Right now we're just kind of focused on setting them up and reducing. So let's try an approximate value one. So it says at the high school football game, 1,217 fans sat on the home team side and 896 fans sat on the visiting team side. What was the approximate, so that allows us to estimate, ratio of home team fans to visiting team fans? So we want home team, we'll just write home to visitor, home team to visitors, and I encourage you to write this every time, no matter what type of ratio problem you're dealing with, because it tells you what goes where. So we want home on the top, visitors on the bottom, and we're going to round. So this here, this is your home team fans, rounds down to 1,200. And your visiting team fans, 896, that rounds up to 900. I'm going to cross these out so we can reduce. So this also equals 12 over 9. And if we divide by 3, we get 4 over 3. So your ratio would be 4 to 3 there. So for every 4 home team fans, there would be 3 visitors. And this tells us that there are more home team fans than there are visitors. Okay? So that's how we use ratios to approximate. And we're going to do one more problem here that's a little different than the ones we have been doing. It comes from a table, and it's a little different. Rosa kept a record of the number of pages and number of minutes she read each night. Find Rosa's approximate reading rate for the book in pages per minute. Alright, so approximate, we see that again, that's going to allow us to round, and it wants our ratio in pages per minute. Okay, we've dealt with some of this before. Miles per gallon, miles per hour. Those are also ratios. So this will show us how we can set up something like that as a ratio. So pages per minute means we want pages over minutes. Okay? So let's look at this here. We've got all these different page number values and all these different number minute values here. So what we're going to do is kind of round and see what we've got here. So on Monday, 15 pages for every 30 minutes. Here, 11 pages for every 20 minutes. I'm going to go ahead and round this one to 10. 14 to 30, which is very similar to 15 to 30, about almost half. So I'm going to say 15 there. 20 to 40, half. 27 to 50, almost half. I'm going to round this one to 25. So kind of the nearest 5, I guess you could say, for the ones place. This is something we can do, because now that we changed these, we see 15 to 30, we're doubling across here. 10 to 20, doubling. 15 to 30, doubling. When we didn't change those numbers, they were very close to doubling from pages to minutes. So if we look at this, we're essentially saying that we're getting one page read every 2 minutes. Just take any one of these, 15 pages over 30 minutes, and if we divide by 15, you get 1 to 2. So your ratio is half. One page every 2 minutes, which essentially says that we're going to get half of a page read, half of a page read every minute. So there we go. Like I said, that one's a little different. So one page every 2 minutes, or basically 1/2 of a page read every 1 minute. So a little different for that one, but just realize that you're allowed to do some of the rounding things like that for approximate values. And this was a little introduction into ratio, which we will be seeing a lot this year and a lot in the future. So we will be hitting this quite a bit. Thank you.